let's learn how to evaluating determinants by using elementary row. On previous study, you learned how to evaluate the determinants by using cofactor expansion and Sarus scheme. So we have another method that can be used to evaluate the determinant. We call it elementary row. So basically, this technique uses the elementary row operation to reduce the matrix to a triangular form. And then we must know how to evaluate the determinant for a triangular matrix. How? By finding the product of the entries on the main diagonal. Recall back, we have three types of ERO. First, we add a multiple of one row to another row. Second, we multiply a row by a constant C. Third one, we interchange two rows. But special for the determinants, when we use elementary row operation, we also can use on column. That means to find the determinants by using elementary row, you can use both column and row. But there are certain effects on determinant when we apply elementary row or column operation. Okay, what type of effect on determinant occur when we apply ERO? The first operation, when we add a multiple of one row or column to another row or column, no effect. The second operation, when we multiply a row or column by a constant C, so the determinant is multiplied by C. And if we interchange two rows or columns, the determinant changes sign. That means you multiply the determinant with -1. Let's try activity 3.4, example 1. The question asks you here to evaluate determinant for this matrix. Okay, so I write it here so that you can see clearly. Okay, if you can see here, the given matrix is an upper triangular matrix. Okay, you check here. All the entries below the main diagonal are 0. So this one is an upper triangular matrix. So how we evaluate the determinant for an upper triangular matrix? By finding the product of the entries on the main diagonal. So what you need to do here? 2 here, you multiply with -3, multiply with 6, multiply with 9, and then multiply with 4. So you will get here -1296. That's how you evaluate the determinant for an upper triangular matrix. Now you try the exercise question number 2. Let's try next example. Okay, the question asks you to evaluate determinant A using elementary row operation. So this is the given matrix A. So the question asks you to evaluate this matrix by using elementary row operation. The first step, you reduce the given matrix to row echelon form or to an upper triangular matrix. Okay, now I will show it to you how to reduce this matrix to row echelon form, and then how we can find the determinant for the matrix A. So the first one here, okay, this entry here now is 0. So what you need to do here? you interchange R1 with R2. Or you can interchange R1 with R3. It's up to you. Okay, so what happened on determinant? If you interchange two rows, the determinant changes signs. That means you multiply with -1. And then you perform the operation here on R1 and R2. So you will get this new matrix. Okay, so next one, this entry here, we change to 1. So what you need to do here, R1 here, you multiply with 1/3. Why? Because we want to find the leading one for this column. So you just multiply R1 with 1/3. So what happened on determinant? Okay, first you copy -1 first here. Okay, now, what happened on determinant? If you multiply a row with a constant C, so if you multiply here with 1/3, so the determinant here you multiply with 3. Okay, so now you perform this operation on R1, you will have here 1, -2, 3, 0, 1, 5, 2, 6, 1. Right, now we check. Entries here, all the entries below leading one. Okay, this entry is 0. And now you change this entry to 0. So that means you want to change R3. So what you need to do, you plus with -2. And then you multiply with the leading one here. So the leading one here is R1. Okay. So what happened on determinant? If you add a multiple of one row to another row, no effect. So you don't have to do anything. You just copy back. So -1 multiply with 3, you will have here -3. So you perform this operation on R3. This one will be 0. This one will be 10. And this one will be -5. Okay, so next one. Next leading one here. And this entry is 1 already. So you don't have to do anything. Now you check the entries below leading one here. Okay, this one. This one you change to 0. So that means you change R3 here. You plus with -10. And then you multiply with the leading one here is R2. So same thing. This operation, no effect on determinant. Okay, so you just copy back here -3. And then you perform the operation here on R3. So you will have here 1, -2, 3, 0, 1, 5. This one 0, this one 0, and this one -55. Okay, now you check. You get upper triangular matrix here. You check here. All the entries below the main diagonal here, 0. So now you can stop your elementary row operation. So from this one, you can evaluate the determinant for the matrix A. So what you need to do here, this one is -3. You just write it back. And now you find the determinant for this upper triangular matrix. So what you need to do, you find the product for this upper triangular matrix. Okay, you find the product for all entries on the main diagonal here. So 1 multiply with 1. And then multiply with -55. So what you will get here for determinant? 1, 6, 5. That's how you do it when you want to find the determinant by using elementary row operation. Okay, so for your task, please try to solve activity 3.5, example 1, exercise 1, and exercise 2. Okay, we try next example, page number 53. Okay, this one quite challenging a little bit. Okay, so if matrix A and the determinant for matrix A is 4, and then the question asks you to find the determinant for this matrix. Okay, so what you need to do? Okay, first, the matrix that you want to find the determinant, you reduce to the matrix A. Okay, because the matrix A here, you know the determinant for the matrix A. So you reduce this one to matrix A. Okay, so let me show it to you how to solve this kind of question. Okay, so our target is to reduce this matrix to be a matrix A. So you always check with matrix A. So we check here. You have ABC here for matrix A, and also we have ABC here. But for this one, ABC at the third row, but this one at the first row. So what you need to do? You interchange R1 here with R3. Okay, so remember what happened on the determinant. If you interchange two rows, you need to multiply with -1. Okay, then you interchange R1 with R3. So now you settle for the first row here. Okay, so next we go for the third row first. Okay, so the third row here only G, H, I, but here you have 2G, 2H and 2I. That's mean you need to cancel out 2 here. So what you need to do? R3 here you multiply with 1/2. Okay, so next you need to remember what happened on determinant if you multiply a row with a constant. Okay, you copy back first -1 here. So if you multiply here with 1/2, so the determinant here you multiply with 2. So you write back, okay, the matrix here, and then you perform the R3 here, you multiply with 1/2. So you only left with G, H, I. So now you get first row and third row. First row and third row. Now we try to settle the second row here. Okay, supposedly the second row here only D, E, F. But here you have -A plus 2D, -B plus 2E, -C plus 2F. So first you try to cancel out here. -A, -B, and also -C. So that means you need to use the first operation. You add a multiple of one row to another row. Okay, because you want to cancel out ABC here. ABC here related to R1. So we will use R1. So what you need to do here? R2 here, you plus with R1. So what happened on determinant? If you add a multiple of one row to another row, no effect. So you multiply here -1 with 2, you will get here -2. And then you perform the operation here on R2. So R2 plus R1, -A plus 2D plus A. You only left with 2D. This one 2E, this one 2F. So this one you just copy back GHI. Okay. So now you check again. DEF. Now you have 2D, 2E, 2F. So you need to cancel out 2. So what we need to do to cancel out 2 here? So R2 here, you multiply with 1 over 2. Okay, so you copy negative 2 first here. So what happened on determinant? If you multiply a row with a constant, so if you multiply here with 1 over 2, that means the determinant you multiply with 2. And then you perform R2 here, you multiply with 1 over 2. So what you will have here, A, B, C. And then this one you only will have D, E, F. And this one G, H, I. Okay, so now you get the matrix A here. Okay, you compare with this one, equal with this one. So now you can find the determinant for this matrix by using determinant A. So negative 2 multiply with 2, you will get here negative 4. So determinant for matrix A. Okay, you can check the question. Okay, what is the determinant for matrix A? 4. So down you multiply here negative 4 with 4, you will get negative 60. And then you solve the question. Okay, if you understand, okay, please try the exercise, page number 53. Good luck. Next example, page number 54. You are given determinant of A is negative 3. And then the question asks you to find the determinant for this matrix. So the idea is same as the previous example. You reduce this matrix to this matrix, matrix A here. Alright, so let me show it to you how to solve for this one. Alright, you check here. We have A, B, C, D, E, F, G, H, I here on row section. But if you can see here, A, B, C, D, E, F, G, H, I here on the column section. So what you need to do here, you transpose this matrix. Okay, remember, transpose means that you interchanging rows and column. So we transpose this matrix. So what happened on the determinant if we transpose a matrix? No effect. So you need to remember this one. If you transpose a matrix, no effect on determinant. So you don't have to do anything. You just transpose this matrix by interchanging rows and column. Right, next one. Okay, I will go for the second row here. I want to cancel out negative here. Alright, so R2 here, I will multiply with negative 1. Alright, so what happened on the determinant? If you multiply R2 here with negative 1. So here you supposedly put negative 1 here. Actually is 1 over negative 1. 1 over negative 1 equal to negative 1. So you just write negative 1 here. So you perform R2 here. And then you multiply R2 here with negative 1. So you will have here 2G 2 hash, and this one you will have negative. Okay, next one. I want to cancel out all the coefficient in front of the A, B, C until F here. Okay, so R1 here, I will multiply with 1 over 3. R2 here, I will multiply with 1 over 2. And R3 here, I will multiply with 1 over 4. You can do it at the same time. No problem. Alright, you copy negative 1 first. Alright, so we check what happened on the determinant if we perform these 3 operations at the same time. So if you multiply here R1 with 1 over 3, so this one you need multiply with 3. If you multiply R2 here with 1 over 2, and this one you must multiply with 2. If this one you multiply with 1 over 4, and this one here you must multiply with 4. So now you perform these 3 operations here on this matrix. So you will get here A, B, negative C, G, H, I, D, E, F, negative F. Okay. Alright, so you see here, we have negative here. So we need to cancel out negative 1 here by performing on column. So that means you perform on C3, then you multiply with negative 1. So remember, when you perform on row or column, the same effect will happen on the determinant. So this one you can write it back, or you just can multiply. So what you will have here? Negative 24. And then you write the effect here is negative 1. And then on C3, on column 3, you multiply with negative 1. Okay, now you check this one and this one. Is it equal now? Not yet. You will see here, for the second row here, D, E, F, but the second row here is G, H, I. So we need to interchange R2 with R3. Okay. So what happened on the determinant? If we multiply, if we interchange 2 rows, you need to multiply with negative 1. So you interchange R2 with R3. Okay, now you can solve the determinant for this matrix here. Alright, so what you will have here? Negative multiply with negative, positive, positive multiply with negative, you will have here negative 24. So what's the determinant for this matrix? Negative 3. So you will get the determinant here is 72. That's how you do it for the example, page number 54. So please try the exercise below this example. Good luck. Third example, page number 55. The question asking you to find the determinant for this matrix, given that the determinant for this one equal to 12. Basically, the idea is still same. Alright, so we reduce this matrix to this matrix by using elementary row operation. So let me show it to you how to solve for this one. Alright, first, if we can see here, this one, FE. But here we have E, F. So that's why first I will interchange C2 with C3. Right, so remember to write the effect on determinant if we do the elementary row operation. So now we interchange two columns. So you need to multiply with -1. So now you interchange C2 with C3. CFI. And this one BEH. Alright, so next one. You check here. ACB. But now we have GIH. So I need to change here R1 here with R3. Okay, you copy -1 first. Right, so now we write the effect on determinant if we interchange two rows. So you need to multiply with -1. So we interchange R1 with R3. So you will have here GIH DFE ACB. Okay, so next one. Alright, so you see here, we have the coefficient -4 here. Alright, -4G here, -4I here, -4H here. So for the R1 here, we multiply with -4. So now, right, so -1 multiply with -1, so you will get 1. So what happened on the determinant? If we multiply R1 here with -4, so this one will be -1/4. Okay, so what you will have here, -4G, -4I, and this one -4H. The rest, you just copy it back. Okay, next step, what we need to do. Alright, you see here for the first row, okay, we have the A here, we have the C here, we have the B here. Alright, all this one, A minus 4G, C minus 4I, B minus 4H. So what we need to do here, so that in front of -4 here, -4I here, -4H here, will we have ACB. So it involves R3. So first you write here R1, and then you plus with R3. Alright, so 1 multiply with -1/4, you will get -1/4. Okay, so what happened on the determinant? If we perform this kind of operation, no effect. So you don't have to write anything. But now, R1 here, -4G. -4G plus R3 plus A. This one -4I plus C, -4H plus B. Right, so this one D, F, E, A, C, B. So we get this one, A minus 4G, C minus 4I, B minus 4H. And this one also we have D, F, E, same as a second row here, and the third row here also now same. So this one actually equal if you write A minus 4G, C minus 4I, B minus 4H. So this one D, F, E, this one A, C, B. So we get this matrix now. You compare this matrix here and this one. Same thing, right? So now we can calculate the determinant for this matrix. So -1/4. So what's the determinant for this one? Equal to 12. So -1/4 you multiply with 12, you will get here -3. That's how the solution looks like. So now please try exercise, page number 55.